Alright, this video is about dispersion and rainbows, and so let's go ahead and get started. So, first of all, we have to know what dispersion is in order to understand why it's important in rainbows. So, the definition of dispersion is the spreading of white light into its full spectrum of colors, and usually this occurs when there's a process that changes the direction of light in a manner into all of its wavelengths. So, the most common example that we have in real life is when white light hits a glass prism. So when it hits the prism, it's going to disperse into its different wavelengths of colors. And we get the array of colors because each color has a certain wavelength range. So violet, for example, is 380 to 450 nanometers, and then it just keeps changing in different increments so that we get the different colors. So that's kind of how we get our rainbow, and then the other thing that we have to understand of why rainbows occur is we have to understand Snell's law of refraction. So Snell's law is as shown, where n1 times sine theta of 1 equals n2 sine theta of 2. So n is the index of refraction, and each medium in the world has a different index of refraction number. And so, for example, if we said that N2 was air and N1 was water, then N1, which is water in our case, is going to have a greater index of refraction than air. And so because it has a greater index of refraction, it has to have a smaller angle in order to make Snell's law correct. And so that's what Snell's law basically is, and we'll talk about the law of refraction when we talk about rainbows, and we talk about why refraction is important in raindrops. So how is dispersion and refraction related to rainbows? So refraction is responsible for rainbows, and the angle of refraction depends on the index of refraction. So as we talked about with Snell's law, and we also said that the index of refraction depends on the medium. And then rainbows are produced by a combination of refraction and reflection. So in this picture here, you can see how in a single raindrop we're going to see both concepts of refraction and reflection. So here we have sunlight hitting the raindrop at an angle, and it's going to bounce off at an angle of refraction and hit the back of the raindrop, which is a reflection, and come back at another angle of refraction. So as you can see, this is where dispersion comes in, because it's going to have the array of colors in the raindrop and reflect, and then when it comes out, it's going to show all of the colors coming out of the raindrop at another angle. It's also easier to see it in here, where all the different colors are separated, and how each color has a different index of refraction. So for example, violet has the greatest index of refraction, greater than red. So because it has a greater, it's going to hit at a smaller angle of refraction, and that's why violet is going to be on top and red's going to be on the bottom. And that's important with the order of rainbows when you see it in the sky, because when you see it in the sky, then you're going to see red first. And so before we talk about how you can see it, I'm going to talk about the angle of incidence. And so this is true for every primary rainbow, and it'll be different for double rainbows at the end. But when sunlight hits a raindrop, we talked how it's going to go red on top and violet on bottom, so it's going to hit. And since the violet has a greater index of refraction, it's going to come out at a smaller angle of incidence at 40 degrees, and red is going to come out at a greater angle at 42 degrees. And this is going to be true. This is always how wide a rainbow is going to be, is it's going to be at 42 degree radius or width. And so in this picture or explanation, so how do we see rainbows? You're always going to see a rainbow if you're looking away from the sun, so the sun has to be behind you. And they also can only be seen if it's in the morning or in the evening. So if the sun is at high noon right above you, then the angle that it's going to reflect is just going to hit straight back up, and you're not going to be able to see a rainbow in a raindrop. So those are two things that you have to know in order if you're going to be able to see a rainbow after a rainstorm. And so this picture helps us understand why we see them. So with multiple raindrops after a rainstorm, is this guy is standing with the sun to his back. So we have two raindrops here, for example, is the sunlight is going to hit and create our refraction and reflection, and it's going to disperse with all the wavelengths of the colors. And each raindrop is going to technically produce a rainbow, but depending on where you're standing, you're only going to see certain wavelengths produced. So even though this raindrop produces red through purple colors, because he's standing here, he's only going to see the red wavelength. Same thing with this one. This one produces red and through violet, but because he's standing here, he's only going to see the violet wavelength. And this is why we see red to violet in rainbows, because of just where we're standing. So that's how we see primary rainbows. And then if we want to see double rainbows has to do with more angles of refraction. So because of the angle that the sunlight hits a raindrop, it's going to have two reflections instead of one, bounce off the back, hit the top, and then come out. And so because it has two reflections, as you can see in this picture, this would be a double rainbow. It's going to hit the white light near the bottom of the rainbow, hit again in the reflection, and then come out. So he's going to see violet on top and red on the bottom. So this is flipped from a primary rainbow just because of that second reflection in the raindrop. So that's all we have to talk about with rainbows. So next time you see a rainbow in the sky after a rainstorm, you'll be able to understand some physics concepts with it.